Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 in November, time zone 0. So question 31, stuff asking for the concept in topic 9 and 19, redox processes, especially the concept about the electrolytic cell running and electrolysis. Let's see. Asking, what are the products of the electrolysis? So now we are searching for the products of the concentrated aqueous sodium bromide solution, so mean NaBr brackets AQ under a concentrated situation. Yeah, so this is going to be a critical point because students are required to know that under a really high concentration, here comes a concentration effect in terms of affecting the preferential discharge of ions, right? So first of all, what we can see is that we should be in our mind having a setup of electrolysis in which a battery connected to both sides electrode. So assuming nothing special about the electrode, so that should be an inert electrode that's just there to conduct the electricity. So remember the skills and the steps that we learned in class. The way to handle electrolysis process is that first of all, we indicate the positive and negative charge based on the battery. So the longer side is plus and the shorter side is not minus. So that will leading to our electrode to be also plus and minus. And according to the logic, the electrolytes will then be containing mobile ions to be attracting according to the opposite charge attraction principle. So that's why your positive electrode will then be attracting negative ions, and your negative electrode will then be receiving and attracting positive ions, right? One side going up to receive the electrons popping down from the negative side, and one side going up and undergo oxidations to donate back the electrons. So that is like the basic working principle behind an electrolytic cells. Right? Yeah, so with this in mind, that the final thing that we consider is what are the ions present within this electrolyte that can be attracted. And eventually we will see under this concentrated NaBr solution, the ions first we have is going to be the Na plus and the Br minus. But don't forget, under aqueous environment, we have water. Water is also a species that can undergo a process we call it the self-dissociation. And with this self-dissociation, eventually protons, H plus, and hydroxide ions are also be released because of water. Yeah, although not a lot, but then still we need to consider both of them, right? So with this bodies in mind, so now we have two ions that competing with each other. So that's why we need to think of the chances or the preferentially discharged position for each of them. And remember, basically we have three factors to consider. And the first factor is being considered using the electrochemical series, basically comparing the strength. And in terms of the strength factor, it is useful for us for this time to indicate and compare the H plus and the Na plus. In this case, H plus is the better choice because H plus is going to be a stronger oxidizing agent. Yeah, so H plus is a stronger oxidizing agent. So it means it will preferentially come and grab the electrons to undergo reduction. So that's why with this understanding in mind, we can notify that the H plus ion is the winner this time, and so go up and receive the electrons. So here comes for the reaction, the half reaction for the reduction, in which the H plus is receiving the electrons and so forming the H2 gas. So that's why we will see one side having the gas bubbles, right? So that's why first of all we can see for the negative electrode side, the H2 gas is going to be the winner. But on the other side, supposedly according to the strength factor, we know that the hydroxide is going to be stronger than bromide. But then because of the concentration effect, so here comes the next effect that students are required to know. Yeah, that is what we call the concentration effect. Concentration effect only applies in the case of halide ion under a high concentration. How high it is for your IB syllabus, you're not required to know. But then you're just required to know if the question just illustrate concentrated combined with a halide ion, so both of these appearing, then this is a really good sign and symptom that we must be considering the concentration effect. So remember, as always, concentration effect only applies to the halide side, and this halide in this case will then take the job of preferential discharge, win over the hydroxide. So that's why for this time, why bromide wins is because bromide has a higher concentration or you can even say a much higher concentration. And so this is what we call the concentration effect. And remember, concentration effect only applies to the case of halide. Remember, so important. Without the concentration effect, if it is going to be a diluted situation, hydroxide will then be a better winner, right? Okay. So with this intention in mind, so we now choose bromide to be the winning position, right? And concentration effect does not apply to the cation side, right? So if with the winners of bromide going up to undergoes the oxidation, so eventually bromine is being formed, right? So we will see maybe some brownish liquid, or maybe sometimes it's even gas to be appearing. So that will be the bromine, and that reaction goes to the bromide, will then be discharging so as to form the bromine plus the 2 electrons. So that is the oxidation process, right? Yeah, so that's why obviously the other side will then be having bromine to be appearing, but not oxygen gas, right? So that's why the answer for this question goes to D.